All right, so I understand you guys are graphing. So which graphs did you go over already? Sine and cosine?
Yeah.
What about tangent?
Not yet.
But you guys, everybody here took regular trigonometry already, right? So you guys kind of know. Anyway, I'm going to start from the beginning, just so we can get this on video for the other class as well. Like, how do you graph y equal cosine x? Well, the key is you graph one period, and then the thing just repeats itself, right? So if you can graph one period, then all you really have to do is just copy and paste as needed, yeah? So the base graph for cosine, I'm sure this is they have all the base graphs in your book, yeah? Plus last year's book too, Algebra 2 and trig, they had the base graphs in there. Anyway, boom, 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 boom. 1 and negative 1. Anyway, the rule for me, because I teach calculus and pre-calculus, honors, and multivariable calculus. So the rule is, anytime you put hash marks, because you're going to have to draw these graphs freehand now on the test, because this is not like the first time you're doing it. Because when you get to calculus, they're not going to give you like lines and grids and things like that. Everything has to be drawn freehand. So the rule is, anytime you put hash marks, if you don't put a scaling, then each hash mark is assumed to be 1 unit, which kind of makes sense. So you can see that on my y-axis, that would be 1 and negative 1. But on the x-axis, since I put this, that means that's 2 pi, that means this would be pi, right? That would be pi over 2. Anyway, there's certain points that you should remember for cosine, yeah? Like cosine of 0 is 1, and then pi over 2 is 0, right? You guys know these points, and then it just repeats itself, yeah? So if you can just remember one period, that's all you need. And then sine. So sine of 0 is 0, sine of pi over 2 is 1, and if you just keep plotting points, you get something that looks like this. Copy and paste after that. So you guys know these already, yeah? So what happens when you graph this then? Because this is the goal. Like, it doesn't matter if it's cosine. Now let's just put a C here, and then a B. And then y equal a sine b x plus c plus d. So did you guys already draw these graphs already as well? Okay, so I'm not sure, every teacher teaches it different, but I try to like simplify it for the student. So anytime you see a graph, it doesn't matter if it's secant, cosecant, tangent, or cotangent either now. What you want to do first, if you want to graph this, you just graph this first of all. You have to do the shrinking and stretching before the translating. Yeah? So what does this do to the graph? Horizontal shrink or stretch, right? And then this one is a vertical shrink or stretch, right? So you have to do this first. So what you do is you graph this, and then if there's this on it, then you go, oh, if it's plus C, then you shift it C to the left, right? And then D up, right? So the key is this is what you want to be able to draw first, no matter which trig function it is. And then you just translate it whatever you have to. So let me give you an example. Like on the test, there are several problems that look like this. 2 cosine. I'm trying to think of something good. Pi over 4 x plus 1 minus 3. We never use the 3 yet. No! Let's put a 3 here and a 1 there. Okay, so how would you draw this graph? Like in the most efficient way. So what you want to do first is just graph this. Graph this first, and then shift it 3 to the left and 1 down. Yeah? Do all the stretching and shrinking first. So how do you graph this? Now, I don't know how your teacher taught you, but like I said, I try to simplify it for you. Did your teacher show you guys this? So what you do first is you just draw the base graph for cosine. Cosine looks like this, yeah? Right? What does this do to the graph? Okay, that's a vertical stretch by a factor of 2, but you know what a better way to think of it as? This will multiply the y coordinates by 2. Did you guys teach? You guys were taught that method? It's the same thing, right? If you multiply the y coordinates by 2, it goes like this, right? So if you think that way though, this multiplies the y coordinates by 2. So watch what I do instead of drawing a whole new graph. Just change the scaling. What does this do right here? That's a horizontal stretch or shrink. But if you think about it this way, it's easier. This will multiply the x coordinates by pi over 4 or 4 over pi? 4 over pi. Just like if you had this. If you had this, just change cosine 3x. This will multiply the x coordinates by 1/3. So it shrinks in like this. But that's fine. It's much easier, instead of thinking stretch or shrink, just think of it. This multiplies the x coordinates by 4 over pi. So that means this thing here gets multiplied by 4 over pi. Now pi's cancel out, and what do you get?
8.
You get 8. So this is now 8. So just change the scaling on the x and the y axis. And then of course if you want to, you don't have to, but you can do, oh then this is 4, and this is 2, and this is 6 then, right? So once you have this graph drawn, now all you have to do is shift it 3 to the left and 1 to the down. So you see your key points right here? All you do is each of these points, I guess I gotta go some more. And that's not really even. Okay, each point gets shifted 3 to the left and 1 to the down. 3 to the left, 1 to the down. So right here, 3 to the left, 1 to the down. That's not 1. 1 is over here. Sorry about that. So I gotta do it. 3 to the left, 1 to the down. Because I forgot that's 2. This point, 3 to the left, 1 to the down. This point, 3 to the left, 1 to the down. And then finally this point, 3 to the left, 1 to the down. And let's do orange. And then copy and paste as needed. I know, that's the way I teach my students. I mean, it doesn't matter what method you're taught, you just gotta do it, yeah? So, what I'm teaching you here applies to every graph, not just trig functions, any kind of function. I don't know, what functions did you guys learn in this class? Y equal x squared, y equal x cubed. It works on anything. Okay, so today what we gotta learn is we've gotta learn tangent, all the others. I'm gonna leave those up. Let's get rid of this. Okay, so what does tangent look like? Because once you got the base graph, I think anybody can do this stuff over here. You know what, just to save time, because we have to end at least 5 minutes early today. Because every Tuesday I've gotta go home and teach a 4 o'clock class. So the period of tangent that I remember, see, what you have to do is you gotta remember one period for each of the graphs. So here's 1 and -1, so it's halfway in between. Like that. Does that look familiar from trigonometry? Okay, so once you get the base graph, then it's easy to do stuff to it. Now cotangent, y equal cotangent x, the period that I remember is this one from 0 to pi. So here are the asymptotes. And then group, and here's 1 and -1, so group, group. Like that. Because when you get to calculus, see, like right now, when you take trig and pre-calculus, like this is the problem. But in when you get to calculus, that's why I'm assuming you guys are taking this class, right? Because you want to go into calculus, whether it's here or in college. You know what the kind of problems we do in calculus? Take this region and revolve it about the x-axis. And you get this like ball of cheese or something. What is the volume of that? Or take this region and revolve it about the y-axis. What do you get? Can you imagine what that is?
Like a fortune cookie.
Fortune cookie? I was thinking bundt cake. But it could, it
But
could
if
be
you
a
cut the bottom half off of a fortune cookie, like, no.
Okay, we'll go with bundt cake. You guys know what a bundt cake is? Anyway, what is the volume and surface area of that bundt cake? That's the kind of problems we do in calculus. But the key is, and you know what the hardest part for my students? Drawing this graph. Because the calculus part is really easy. You know what the hardest part of calculus is? It's the pre-calculus. Students cannot remember their base graphs. They cannot work with logarithms. They forget logarithms and their trig identities. Things like that. They forgot how to factor. They forget synthetic division. All the stuff that you learn in pre-calculus. Yeah? Okay, now what about secant and cosecant? How do you draw that? Well, I'm going to do it right here. I don't know what your trig teacher taught you last year. Did you guys learn the humping method? Okay, I'm going to teach you how to hump then. Right here. Okay, so what if you want to graph y equals secant x? Now, of course, isn't secant x the reciprocal of cosine? Okay, you guys know that, right? So what you're going to do is take this graph, and you're going to take the reciprocal of every y coordinate. Right? Because you plug it into here, you get a y coordinate, and then 1 over that. So take the reciprocal of every y coordinate on this graph. Now, what's the reciprocal of 0? And don't say 0. Okay, here's 0. 0 over 1 is 0. What's the reciprocal of that? You flip it over. Undefined. So the reciprocal of 0 is undefined. So whenever the graph touches the x-axis, you're going to get a vertical asymptote. Right? Because that's what you draw, right? When it's 1 something over 0. And then the y-coordinate here is 1. What's the reciprocal of 1? Here, I'll even draw it. Here's 1. 1 over 1. Flip it over. You get 1. Okay, but over here, like half. Here's half. What's the reciprocal of 1/2? 2. So then the graph goes up here. So, are you guys sure you didn't learn this? So if you have the graph of cosine and you want to graph secant, you just hump. If the graph humps down, then you hump up. If the graph humps up, you hump down. When it's humping down, you hump up. So now does that sound familiar? Hump. I'm pretty sure lots of books draw it like that too. Hey, so Mr. Park, can we do that for cosecant? You bet your baby you can. Look, y equal cosecant x. That's the same thing as 1 over sine. So you just do the humping method. So the first thing you do, whenever the graph touches the x-axis, the reciprocal of 0 is undefined. So you have vertical asymptotes like this. And then, if the graph humps down, you hump up. If the graph humps up, you hump down. And it doesn't matter, like if I'm trying to teach you stuff that'll help you, but if you want to just use what your trig teacher taught you last year, then do that. But the key is you gotta know these base graphs, because then now, okay, how much time do we have? Okay, let's do okay, we'll pick one of these. Somebody pick one, tangent or cotangent?
Cotangent.
Okay, cotangent. Graph this. Now on the test, you have to, it's the directions on the test, it's going to say graph 2 periods. Okay, so if you can graph 1, then you just copy and paste 1 time and you got it. Okay? Okay, how about this? -2 cotangent pi over 2x plus 1. And we're not going to even shift up or down, we just do this. So how am I going to do this? So what is the first graph I need to draw? Y equal -2 cotangent pi over 2x. So the key is you want to draw this graph. Once you got that down, then you shift it 1 to the left, yeah? Okay, how do I graph that? Well, the first thing you got to do is remember 1 period right here. So the period that I remember is from 0 to pi, and then it comes down. Okay, what does this do to the graph right here? This will multiply the x coordinates by 2 over pi, the reciprocal of the number. So if I multiply this by 2 over pi, what are you going to get? You're going to get 2. 2. Oh, that means 1 here then. You don't have to put the 1 there. See, once you put a scaling on there, it extends for the whole x-axis. Now, what does this negative 2 mean? Well, what does the 2 mean? That multiplies the y coordinates by 2. And what does the negative do? It reflects it over the x-axis. So, what happens is, it goes from 1 to 2. So basically, it just stretches it out more. So it's more like this now. I mean, that part, it's really hard to see. And then the key is you got to flip it over the x-axis. So when you reflect it over the x-axis, it's going to look like this now. Okay, so this is the graph of this. But we need to graph this. So what does this do again? It shifts it 1 to the left. Okay, let's get another color. We'll do orange. So everything on this graph shifts 1 to the left. So what I like to do, I like to just do the asymptotes first. So here are the asymptotes. Both asymptotes shift 1 to the left. So here they are. And then the graph is going to, I guess we should put the 2 and the negative 2. Maybe that might make it easier. Yeah, sorry. Close enough. You see the orange graph? The orange graph is the one you want. And then just copy and paste. So you can either copy and paste here and here, or you want to go there to there. I think it's, I'd rather go here to here. And then, yeah. There, 2 periods right there. Okay, and then we'll do either secant or cosecant. Which one you want to do? Pick one. Secant. Okay. So let's erase. I'm trying to give you problems you're going to see on the test, that's why. So graph 2 periods of this. Y equal 3 secant pi over, pi over, we never did 8 yet, then x minus 5, no, 3. Yeah, there we go. Oh, but I don't like that 3 there, change it to a 4. There you go. I like to see different numbers. Okay, so what should I do? I'm not going to even make you shift this one up and down. I think the only ones I'm going to make you shift up and down are sine and cosine. All the other ones, I'm not going to even worry about a vertical shift. So this is what you want to do. Graph this first, and then shift everything 3 to the right. Okay, so how do I graph this? First you draw the base graph. One and negative 1. Okay, so when I graph secant, the first thing I do is I graph cosine, and then I hump it. So cosine looks like this, right? You guys remember how to hump? How do you hump the graph? When the graph touches the x-axis, there's going to be a vertical asymptote, because the reciprocal of 0 is undefined. And then if the graph is going down, you hump up. If it's humping up, you hump down. If it's humping down, you hump up. There's the graph of secant. What does this do to the graph? It multiplies the y coordinates by 4. So instead of having 1 and negative 1, it's going to be 4 and negative 4. Just change the scaling. If you want to graph a whole nother graph, you can, but try to save time here, right? What does this do to the graph? It will multiply the x coordinates by the reciprocal of that number, 8 over pi. So here's 2 pi. If I multiply that by 8 over pi, the pi's cancel out. And you get 16. So this becomes 16, which of course means this is 8, and this is 4, and this is 12, if you want to put that in. It's up to you. Okay, so that's what this graph is. So all I have to do now is shift everything 3 to the right. So let's take out the orange one. So here we go. Everything gets shifted. So I do the asymptotes first. So here's the first asymptote. So it's going to go from 4 to 7. Then this one goes from 12 to 15. Everything gets shifted 3 to the right. So this point here gets shifted 3 to the right, and then it's going to hump up. This point here gets shifted 3 to the right, so it's going to go from 8 to 11, and then it's going to hump down. And then this point here is going to go, wait a minute. My graph is not that good, that's why it's supposed to go over here. So this point here will go from 16 to 19. Here's 20. So 16 to 19, and then it's going to hump up from there. And then all you have to do is copy and paste. So take this and you can either paste this way or paste it that way. It's up to you, because you're going to have to graph 2 periods on the test. All right, so any questions on this? So how did you learn how to graph before? Did you guys have to make separate graphs for everything? I'm trying to simplify it so you don't have to make as many. Well, it's up to you, like I said, because you guys already learned this before. If you want to do what your trig teacher taught you, that's perfectly fine too, because the graph is going to come out. So what I did when I found out I was subbing for your class, I found out that I had to make a test. So I made Friday's test already. And so what I did is I made a practice test, because that's what I do for all my other classes, my pre-cal honors, advanced placement, calculus. I don't do it for multivariable calculus. But for all my classes, I give them a practice test before they take the real test, because it just makes it easier, yeah? So for you, since this is the first test that you're going to see from me, I'll tell you what I did. I made the test first, and then I copy and pasted it into another document, and then I just changed the numbers. So it's going to be exactly the same as the test, except you're going to have different numbers. So for example, instead of a pi over 2 here, I might change it to pi over 4. Is that going to throw you off?
No.
Instead of a cotangent, I might change it to tangent. So I'm going to put it in the Shobi folder. Actually, I think I put it in already. I think it's in there. So do you guys have you guys have an assignment for tonight for drawing these graphs, yeah? So do this assignment first. I don't know what it is, but just do your assignment that Ms. Baker gave you. And then after you finish that, for your next homework to prepare for the test, so I don't know if you're going to do it the night before or whatever works for you. If you can get through that test on your own, that means you're going to do well on the test. All right? Makes it easy for you. And on top of that, tomorrow morning I'm going to come into school early. I'm going to make complete solutions for the practice test, and I'll send it to you.
Thank you.
Okay, you're welcome. All right, yeah, that's extra work for me, but I think it's going to help you. So, all right, what time is it? 10 minutes? Oh, okay, I want to leave in 5 minutes, but we got 5 minutes left. So, in my other classes, when we finish early, you know what we do? We play games. Okay, what time is it? Okay, we can play for 5 minutes, so it's not going to be that long. Who knows? Because on Friday, we can't play the game because you got the test, right? What do you get? Oh.
don't need that much, but I'll.
Okay, but I can't, oh, you gotta work now then, because I gotta
Yeah,
leave.
yeah, I said I can't.
Okay, what's your name?
Ian, so.
Okay, work in the back here. Oh, let me turn off the camera.